We're going to take a look at two learning targets today. The first, I can write a system of equations to model a real-world situation, and then I can solve a system of real-world equations. So let's take a look at what you need to know. When we go to set up a problem, we have some steps we can follow. The first is that we want to define the variables that are given to us in our problem. Secondly, we want to write two equations that model the situation. Third, we want to solve the system by either graphing, substitution, or linear combinations, which is elimination. And then lastly, answer the question that was asked. If you'll remember, there were three methods to solving systems. Those are talked about in step 3. But once you've written your two equations, you can solve them using any method that you'd prefer. So in example 1, the school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior citizens tickets and 2 child tickets. We want to find the price of a senior citizen ticket and the price of a child ticket. So once we're given the problem, it's a good idea to go kind of back through, maybe reread, highlight parts if you need it. But in our first step, we want to define the variables. So what are the unknowns that we are looking for? We are looking at a choral performance. They're selling tickets. And there's two types of tickets. There's senior citizen tickets and then there's child tickets. So we're going to go ahead and let S stand for the senior citizen ticket and C stand for child ticket. I typically like to use whatever letter the word that we've identified as the variable starts with. It just kind of helps keep things clear in my mind as I move through. Now, step 2 is to set up the equations. So as you can see here, we have 2 days of ticket sales. And you can go back and kind of look here. It says on the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. That is where this first equation is coming from. So 3 times senior citizen tickets, or the cost of the senior citizen ticket, plus 1 child ticket equals $38. And then it goes on in that next sentence that the school took in $52 on the second day, and it sold 3 senior citizen tickets and then 2 child tickets. And we want to find the price of both the senior citizen ticket and the child ticket. So now that we have our two equations written, we can go ahead and solve for the variables. You can choose whatever method you'd like. I've chosen to use elimination because these are both set up in standard form. My S variable already have the same coefficient. They both have those 3's, but I'm going to go ahead and change the bottom equation to a negative so that I can subtract or eliminate my S's. So when I do that, my S term is going to cancel, and then I'm going to have 1C minus 2C, which is going to give me negative 1C, and then 38 minus 52 is going to give me negative 14. When I go ahead and finish solving that, I'm going to divide both sides by negative 1, and then C is going to equal 14. So the cost of my child ticket is 14. But we have to go ahead and figure out what is the value of S, or my senior citizen ticket. So we're going to substitute that back into my equation. You can pick either equation. So I'm going to plug in 14 for C. When I do that, I end up with 3S plus 14 equals 38. We subtract both sides by 14. 3S now equals 24. And to get S by itself, we have to eliminate the 3's by dividing, because that's the opposite of multiplication. So the cost of my senior citizen ticket is going to be $8. We want to make sure we answer the question completely. It says that we want to find the price of the senior citizen ticket and the price of the child ticket. So I know that the senior citizen ticket cost $8 and the child ticket cost $14. Okay, so now it would be a great time to pause, go ahead and try number 2, and then come back to check your work. In this example, we have the State Fair is a popular field trip destination. This year, the senior class at High School A and the senior class at High School B are both planning trips there. It tells us that the senior class at High School A, they rented and filled 8 vans and 8 buses with 240 students. And then High School B, they rented and filled 4 vans and 1 bus with 54 students. Every van had the same number of students in it as did the buses. So we want to find the number of students in each van and in each bus. So remember, the first step is to define those variables. So we're trying to figure out the number of students in each van and each bus. So those would be our variables because those are our unknowns. That's what we're trying to find. So V for vans, B for buses. Step 2, we want to set up our equations. Remember that in this case we have 8 vans and we have 8 buses, and then we have a total of 240. So whenever we have that total like that, we're adding 2 parts together to equal a total amount. So 8 vans plus 8 buses equals 240, and then High School B had 4 vans and then 1 bus with 54 students. So that's how I got my 2 equations. The third step is to solve for the variables. So you could choose whatever method you like best. I've chosen to do elimination again. So in this case, I am multiplying that bottom equation by -8 so that my B or the buses will eliminate. So in order to do that, don't forget you have to distribute that 8 all the way through. So I'm just going to rewrite my equation. So I rewrote the top equation, and then my bottom equation becomes -24v minus 8b, and that's going to equal -432. When I do that, those 8b's, they canceled. And then I continue to solve. So 8v minus 24v gives me that -16v, and then 240 minus 432 gives me that -192. Then to get v by itself, since -16 is being multiplied, to undo that multiplication, we divide. So we divide both sides by -16, and v is going to give me 12. So that the number of students in each van is 12. Now, to find your second variable that's missing, we use substitution to find that variable. So you can pick either equation. I'm just going to, I guess I picked the bottom one here since the numbers were smaller. And then I go and I plug in the value for v that I solved for. So I plugged in 12 for v, and then we go ahead and simplify. So 48 plus b equals 54, and now I need to solve. So to get that 48 away from b, since it's being added to the b, we would subtract it from both sides. So I'm going to have 1b equals 6. So my answer is just 6 for the number of students in each bus. If you need more help on this topic, you can check out the Learning Target spreadsheet for additional resources, videos, and practice.